Okay, so this is a thinking one, not a math one. Oh no, I have to think. Okay, a teacher creates a wave in a rope which is fixed at one end to wall by sending pulses through the rope by simply moving her hand and flicking the rope up and down. Describe what would happen to the wave's amplitude and speed if the teacher puts more energy into the wave without changing the frequency of her hand's vibration. So if more energy was put into the wave without changing frequency, so without changing how fast it's going up and down, but if you put energy into it, the amplitude can increase. So it's the wave is either bigger and goes down deeper without making it go faster. So for A, amplitude increases, but speed stays the same. Because the medium is not changing. Remember, if you keep that medium the same. In our notes it says if the medium changes, the speed of the mechanical wave will also change. But if it stays the same, it doesn't need to. Now go back to your go back to your front page and remind yourself, look at where you showed me what amplitude is, right? It's how high or how low the wave is. So that's what was changed in this A, this part A, was the amplitude. So just how high or how low, but frequency is related to how fast, right? So B, describe what would happen to the wave's frequency and speed if the teacher puts more energy into the wave by increasing how fast her hand vibrates up and down. So for B, frequency increases, but speed of wave stays the same. So the speed of her hand changed, but the actual wave speed didn't. Because medium is not changing. Yeah, let me just finish this one. Just the note, and then I'll talk about it more. Note the wavelength will decrease. So if we write out our actual formula, it might help with some of just the thought. So if B is equal to frequency. So if I increase the frequency of the wave, but speed needs to stay the same, because only the wave will only change its speed if the medium changes. So if it like went from air to liquid, that's when the speed of the wave would change. So if I can increase the frequency of how much the actual wave is going, so let's just go back to our definitions, because sometimes it's hard to talk about this with our definitions. So if our frequency has increased, because that's the number of complete wavelengths that can pass a certain point in 1 second. then what needs to change if the actual speed of the wave has not changed? Well, the wavelength. So what, we need to draw it, would help you guys.
Can you just like do the example of the slinky? It's like the way it's written.
Yeah, let me just try one more thing, and then maybe we can do a slinky. So if, like, let's say this is our initial wave, okay? This is our initial wave. So with, say, part B, the wave's frequency increases, but speed stays the same. So what needs to happen is that I need to have more waves in the same amount of time. Okay? More waves in the same amount of time. Okay? So the actual wavelength has decreased from my initial. Here's my wavelength initially. Here's my wavelength in B, situation B. So the wavelength has gotten shorter. Amplitude should stay the same, yeah. So let's draw a diagram for A then, too. So if amplitude changed from our initial, it increased. Say this is our equilibrium, and this is our, let's say this is our initial. Oh, that's bad, it's not in the middle. I draw it again. So for A, say this, the red is our initial. If amplitude increases but speed stays the same, I need to have a bigger amplitude, okay? So it goes up higher and comes down lower. So this is increased amplitude. And this one is increased frequency, which means a decreased wavelength. Okay, so you want to try this with the slinky to kind of get a visual?